Welcome to the 9.2 BoxPlots notes. Make sure your name is at the top and you have a pencil before you start. Here on the left side, you'll realize we have some probably new words. The first thing I'm going to point out is that there is this new word called quartile, and the first 5 letters spell quart. Quart means 4 because there are 4 quarters in a dollar. There are 4 quarts in a gallon. So what this means is we're going to be splitting our graph up into 4 parts. The lower quartile is going to be the middle number of the lower half of the data, because we are going to split the data in half using the median. So the median is going to be the middle number, and the lower quartile is going to be the median of the lower half of the numbers, and the upper quartile is going to be the middle number of the upper half. And what this looks like is the lower quartile, or LQ, are going to be the first line right here. The median is going to be the line in the middle of the box. And the upper quartile is going to be the right side of the box. What this does is it gives you an idea of where most of the data values fall. In fact, since we are splitting this graph into 4 parts, the whisker over here that goes to the minimum, the whisker over here that goes to the maximum, and then each half of the box. Those are each 4 parts. Each one is 25% of the data. I'm going to say 25% of data in each quartile. So one quartile, or one section, will be 25%. But if we put 2 of them together, like from here all the way to here, that's 2 of them in the middle, that's 50%. 3 of them will be 75. And if you get all 4, you have 100% of the numbers, because everything's going to fall somewhere between the maximum and the minimum. Then we have a special name for the box itself. So all of this area right here inside of the box is called the interquartile range. Inter means in between. Quartile means the box, because you're in between the lower quartile and the upper quartile. And we are going to calculate it by calculating the upper quartile minus the lower quartile. And since I'm talking about range, I'm going to add a little bubble over here like this. And I'm going to say that range, regular range, is max minus min. So the interquartile range is kind of the same thing as range, but for the box. Now let's practice how to find these first, and then we'll try and draw the box and whisker plot, or just simply box plot. The first example shows the speed of 9 pitches in a baseball game. The first thing you need to do is put them in order. So 80 is the lowest, then 83, then 85, then 78. Oops, I need to put that back at the beginning because I skipped it. Then 87, then 91, and 93, and 95, and 97. Then what you do is you lightly cross off one on each side until you find the middle. 87. That's your median. Then it's super easy. What you do is you cross one off on each side on the left side, and you get 80 and 83 left in the middle. Remember that if you get two numbers, you either need to find the middle number or add them together and divide by 2. Either way you do it, you're going to get 81.5. For the upper quartile, we have halfway between 93 and 95, which is a little easier. That would be 94. But if you didn't know that, you could always add them together and divide by 2. So if you're trying to do a median of any type, and there's two numbers, you average them together by adding them and dividing by 2. Now I need to be able to graph this, so the lowest number I needed was 78. And then I'm not going to write 79, but I'm going to leave a spot for it. I'm going to write 80 afterwards. So I'm skipping a line and a number in between just to save myself time. Now, I end up on 96, but my highest number up above was 97. So I'm just going to draw an extra mark right there. Sometimes you need a few extras, that's all it takes. Then, my lower quartile was 81.5, which is right here, halfway between 81 and 82. The upper quartile was 94, and the median was 87. And then you go ahead and draw a box out of all three of those, like so. Then you also need the min and the max as the whiskers. The maximum was 97, and you draw a whisker. The minimum was 78, and you draw a whisker to attach it. There you go. That is a box and whisker plot. Then it's going to ask you a few questions afterwards. It asks what the interquartile range is. Remember, that's upper quartile minus lower quartile. So 94 minus 81.5, which is 94 minus 81.5 is 12.5. Then it asks us what percent of the data falls between 87 and 89, or sorry, 87 and 97. 87 is right here. 97 is all the way over here. So that covers 2 quartiles, which is 50%. All right, second example. This data shows how many minutes it takes to get 10 people to get to work. We're going to list them in order first. We have 8, 10, 12, 14, 15, 17, 19, 20, 22, 28. Then you just cross one out, highest and lowest, highest and lowest, highest and lowest, highest and lowest, till you realize that the middle is actually 15 and 17. Halfway between 15 and 17 is 16. What that means is 15 gets counted on the left side, 17 gets counted on the right side for the lower and couple upper quartiles. So then I cross one out and cross one out, and 12 is our lower quartile. Then I do the same thing on the upper half. I cross off 17 and 28, 19 and 22, and 20 is my upper quartile. My minimum was at 8, so my number line needs to start at 8. And then I'm going to go by 2, skipping a line in between. But I only get up to 26, so I'm going to add 2 lines with a 28 because that's my maximum right here. So my maximum is 28, my minimum is 8. Then the 3 numbers I found for my medians were 12 is my lower quartile, 16 is my median, and 20 is my upper quartile. We just make that box out of all 3 of those. And draw little whiskers that go out to the maximum and the minimum. Like so. Then it asks you for the interquartile range. Again, that's upper quartile minus lower quartile. So 20 minus 12, which is 8. And it wants to know what percent of data falls between 8 and 20. Here's 8 all the way over to 20. That's 1, 2, 3 quartiles, which is 75%.